lead to an apparent association, even if one does not really exist. Or can lead to apparent lack of association when one does in fact exist. Or can lead to an apparent lack of association when one does in fact exist. Or can lead to apparent lack of association when one does in fact exist. So the whole thing one more time. Can lead to an apparent association even if one does not really exist, or can lead to an apparent lack of association when one does in fact exist.
And I would add "and" in there, or lead to an apparent lack of an association. We're going to do it one more time for those who are joining us on the web. I'll read it. All right. Can lead to an apparent association even if one does not really exist, or lead to an apparent lack of an association when one does in fact exist, period. And we can see that it could have gone the other way, right? They could have not recalled as much, right? And then the boxes make them look different, okay? So here we see a positive relationship, okay? That's not valid though, right? But we could have also not had a relationship that was invalid as well, depending upon how that exposure variable was collected. We got that? All right, finish. Go ahead, continue.
Can exaggerate or underestimate the true exposure-disease relationship. By chance and frequently can also result in an estimate that is the same as the true exposure-disease relationship.
All right, so are we clear? All right, very good. Next, what's next? NDMD, correct? All right, NDMD. NDMD. The portion of subject misclassified on exposure does not depend on disease status or vice versa. Okay? The portion of subject misclassified on disease does not depend on exposure status. Okay? Just keep that in mind. Okay? Because this non-differential, remember what are the key words here? Not different. Okay? Let's go back. Can we go back to the differential? All right. So when we say that we have an association, okay, when we say that we have an association, okay, we say that there is a what? Okay, there's a relationship. Okay, what else? Something simple. We say that there's a difference. Okay, there's a difference. There's a relationship, correct? Right? That's what that means. So the test is what? H naught, OR equals 1. Two-sided test. Alternative is OR not equal 1. Okay? No difference, difference. Right? All right. So what happened in the what? The differential misclassification, right? You said that there was a difference, right? Because you said that there was an association, a positive association between mild infections and malformation, right? Meaning that there's a difference, okay? I don't know if that helps somebody, but I just thought I'd throw that out there when you're trying to study, okay? And that's why I told you to circle difference. Help me, don't all right, so non-differential, that's what we are. Okay, so really, Doesn't have anything to do with, how I or the participant, documents the exposure, or how the participants documents the outcome, okay? So this one is a little different, NDMB. We can turn this off. All right. So, you can use your notebook paper, Mom? Okay. Got it? All right, so NDMB. All right, so NDMB results from the degree. So results from the degree of inaccuracy. So results from the degree of inaccuracy that characterizes how information is obtained from any study group. Okay, results from the degree of inaccuracy that characterizes how information is obtained from any study group. Either cases or controls, or exposed and non-exposed participants. Okay, so results from the degree of inaccuracy that characterizes how information is obtained from any study group, either cases and controls, or exposed and non-exposed participants. I had you all write this in sub-bullets, right? All right. Okay, next bullet, okay. It's not related to exposure status or case control status. Okay, so not related to exposure status or to case control status. Okay, next bullet. Okay, problem, it is a problem inherent in the data collection methods. Okay, problem inherent in the data collection methods. All right, so not related to exposure status or case control status, number one. Number two, problem inherent in the data collection method. Okay, number three, the usual effect of NDMB. Okay, so the usual effect of non-differential misclassification bias is that the RR or the OR tends to be diluted and is shifted towards the null value of 1.0. Okay? So the usual effect of NDMB is that the RR or the OR tends to be diluted and shifted towards the null value of 1.0. If I have an RR or OR of 1.0, what am I saying? No association or what? Not, no relation. No different. Okay, and what are we looking at right now? Non-differential misclassification bias. Is it coming together for you a little bit? Okay, so we'll put it together with some examples. All right? All right, so what's the usual effect of the NDME?
That the RROR tends to be diluted and it shifted towards the middle value.
Okay, so here we are less likely. Okay, we are less likely to detect an association if one really exists. Okay, so here we're less likely to detect an association if one really exists. Which means that they are not different. Remember, non-different. All right. Less likely to detect an association if one really exists. All right, so let's look at it. Okay, so my example. Okay, so here, this is a positive relationship, okay? Just putting that out there. All right, so in reality, we have a strong relationship or association between exposure and disease, right? So in reality, there's a strong relationship or association between exposure and disease. Okay, so in your mind, theoretically, okay, which group should have the most exposure? Those with the disease or those without?
With the disease.
Okay, so those with the disease should have most exposure, right? If there's a positive relationship in the world. All right, so again, in reality, there's a strong association between exposure, between an exposure, and a disease. And what you just told me, you just said those with disease have more exposure than those without disease. Okay, so those with the disease have more exposure than those without the disease. Got it? Okay. Second point, okay, or conversely, those without the disease should have what? Very good. Okay, so those without disease, okay, have less exposure than those with the disease. Okay. All right, so tell me one more time. So in reality, there's a strong what?
Association.
Okay, between,
Exposure and disease.
all right, so those with the disease have
More exposure.
compared to,
Those without disease.
okay, and on the other hand, those,
Without the disease. Have less exposure than those with the disease.
okay, y'all got that? Right, so, non-differential misclassification bias. Remember, we said it wasn't related to whether or not you were exposed or not exposed, or whether or not you were a case. It was something that was incorrect, right? Or done incorrectly in the data collection process, right? All right, so here, what has happened is the researcher mistakenly includes some disease participants in the control group and some non-disease participants in the case group. All right, so what has the researcher mistakenly done? Included
Disease patients.
disease participants in the
Control group.
control group and some
Non-disease participants
Participants in the what group? Okay, let's do it one more time for those of us who didn't get it, okay? So, problem inherent in the data collection method, remember that? All right, researcher mistakenly includes what? Some disease participants, okay, in the what group? Control group. And some non-disease participants, in the case group, okay? Do you see the mistake? Y'all see it? Okay, so now we have cases and controls being misclassified, okay, by the researcher. So I put some people here, some people here, but these people should have been here, and these other people should have been there. Y'all get that? One more time. Y'all have it? All right, so let's look at it. Oh, I kept you up here so you could point. All right, so researcher mistakenly includes some cases in the controls and some controls in the cases. Does that make sense? All right, so what has the researcher done? The researcher has misclassified in regard to diagnosis, okay? Researcher has misclassified in regard to diagnosis. All right, so what do you think will happen? Okay, this is a critical thinking moment. All right, so what do you think the controls will look like? So you said that if there's a positive relationship, then the controls will have less exposure, right? Compared to the cases. Am I on the right page? Do we all follow? Positive relationship exists, then what do we expect? We expect that the controls will have less exposure than the cases. But if I misclassify, okay, if I, me, the researcher, if I've misclassified on the basis of diagnosis, and I've put people into incorrect groups, does that make sense? What do you think the controls might look like?
They have exposure, more exposure.
They will have what?
More exposure.
Okay, compared to what it should look like, right? Or what we expect, right? So controls have more exposure than what we would normally expect, right? Okay, why?
Because you misdiagnosed according to the diagnosis. Because he misdiagnosed. Misclassified in regard to diagnosis. Yeah.
Okay, 1, 2, 3, 4. All right.